All right. Thanks, Good, for breaking down what digital twin actually mean for us and how to build one. We have seen a lot of 3D models, 3D contains, and beyond visualizations, 3D data can also be used for analysis as well with GeoAI. And this is why we're talking about AI across ArcGIS now. So ArcGIS is a geospatial AI platform, and it's being enhanced with AI. We have seen quite a lot of a couple of demonstrations earlier today on how you can now use AI assistant to query your layers, to search for the right tools or search for new tools that you've never used before, or for apps creation, translation, and so on. So we are currently also building AI frameworks that includes new AI services, new AI models, new AI apps, new AI tools that help you to do your work. And this is with the aims of we want to better integrate AI capabilities within ArcGIS. Another part that's very important within AI across ArcGIS is the GeoAI analysis. So when we talk about GeoAI, it's really about how you can do prediction analysis with vector, raster, or time series data in TimeCube. And this is through GeoAI tasks, whether it's feature extraction, object detection, and so on. And what we found is GeoAI tools, it's particularly good at text documents and imagery, different type of imagery. We have added a lot of GeoAI models to ArcGIS Living Atlas. So ArcGIS Living Atlas is a platform that you can get authoritative data and also models that we put up there. And we're still constantly adding more and more models onto the platform too. Wait, there's a slide that's missing. I think I accidentally moved a slide. So we just do this. You guys can see that. So the New Zealand models, this list is growing. We just added a New Zealand land cover classification models onto ArcGIS Living Atlas last September. And this means that we either localize the models from overseas models, or we just train one from scratch. And it's expected to work really well with New Zealand data. There is another slide that I deleted or moved somewhere. But where we got this idea from, it's from Cratchit, NZEUC 2 years ago, where we just asked all the users within the sessions, what is the models that you guys want the most? And then we work with the local university, University of Canterbury, to create this model, to train these models together. So on the previous GeoAI model list, some of this that I wanted to highlight is how you can now use AI models to help you to digitize your hard copy maps. So if you think about how many hard copy or physical maps you have in this library, say making a safe assumption of 500, and if you take 1 hour to digitize one, you will need 500 hours. If these models can't do 90% of the digitization for you, say 50%, you're already saving 250 hours. Beyond edge detection, you can also extract out the text as well for indoor plans and for outdoor on the city levels on the parcels. Oh, this is where my slide is. So we did get the ideas from the communities. So land cover classification models. On the left side, this is showing the US model. We didn't train it right away. We did test out the models that existing. So why we want to retrain it? Because the US model is trained with the data sets from California, and it's generally really dry over there. That's why it seems like it's almost flooding just in the scene. And after localize it with New Zealand data, New Zealand area imagery from all around New Zealand, you can see how well the model is performing right now. I also want to point out this new model, prompt-based segmentations. So it does look quite similar of what it does compared to TextM, but it's actually very different due to the backbones and the model architectures behind it. With TextM, essentially you have grounding dynos and segment entity models together. So running two models at the same time requires a lot of GPU power. That's why it requires 8 gigabytes of virtual memories on your GPU. And we understand that not every machine can run that. That's why we want to provide the second options for you to do pixel classification, still allowing you to use a prompt to get segmentation out of that. And prompt-based segmentation gives you a raster as an end result, and it's lightweight, but it can only do just one object or one class. And on the other hand, TextM allowing you to use one prompt to segment out multiple objects. Everyone loves trees. That's why we put a lot of efforts, resources to try to find a way that we can extract tree or visualize trees. We used to need to rely on algorithm, density-based clustering to get a tree canopy. And then you can now use use GeoAi models to extract tree from area imagery, satellites, point clouds, and now you can even do canopy height estimation. Using this model, it doesn't just give you the canopy width, you can also get the height of the tree so that you can get the canopy volumes or the trunk height as well. So it really gives you the extra dimension or information that you won't get if you're just using area imagery to extract trees from it. ArcGIS is also an open geospatial AI platform. This means we integrate AI capabilities into ArcGIS in multiple ways, which I will go through later. But how it works is, doesn't matter how we bring an AI service or AI models into ArcGIS, we standardize it into deep learning package format, and that's how we can support it within the platforms across multiple apps. The first integration way is we tightly integrate AI models. In this case, it's Mistral, the large language models, into the tools. So you don't have to do anything, click the drop downs, and you can use it right away. Use it as it is, or use it to train a custom models, a new NLP models for your use case. We have also seen this in the ArcGIS Pro session earlier today, how you can host models on your Azure AI Lab, and then you can just use a connection file and connect to that models and start using that. We used to have this quite disjoint workflow where if you started your AI works somewhere else on another platform, RoboFlows, SageMaker, it's quite hard to bring it into ArcGIS. So now we have made the improvements, enhancements that you can import your training chips into ArcGIS Pro. We even provided script that you can just use to convert your data in your training chips into Pascal Vault format, which is very common in the AI world. You can also export your training chips to cloud storage as well. Because if you're training a models, it involves a lot of training chips. And if your virtual machine or your laptop or your server is not that big, or you just want it to be more modern, efficient, you can export it to the cloud storage through these cloud connections. Just by changing the output folders and then point it to that file. This is a new model hubs, Hugging Face hub integrations that we have. So what it means is we open the doors for you to bring in models yourself and you just use it right away. You can just copy the model ID from the model cards and then you just paste it into ArcGIS Pro, into the parameters, Hugging Face ID, and you can use it right away as long as the models have a JSON files as a formats that we are supporting right now. Now I'll do a quick demos to just show you. This is one of my favorite models in the recent batch, pedestrian infrastructure classifications, that help you to create a whole new layers that I've never seen before. Maybe you have. So this is in ArcGIS Pro right now. After running the models, the new models with area imagery, you can now see that we get a new layer in raster form that gives you sidewalk, route, crosswalk, and backgrounds. If we use a slider on this raster layer, we can then see the cross-section is actually getting classified quite accurately. But in real life, the cross-section looks very differently because there's different type of cross-sections. So this is a good example to show why AI models is different than computer vision, because we are not using algorithm. We are really getting the models to learn the general knowledge of what cross-section actually is. There's also off-road, different type of cross-sections that we're looking at here. Cross-section that's partially obstructed and hence is not getting classified. But if the cross-section is only getting blocked by a lower percentage, the model will still be able to classify it as cross-sections. Another side that the model did really well is helping us to find the path that will take. It's not sidewalk, it's not crosswalk, it's not any roads that we've previously known. So those are the small paths that maybe you will exist in a park or on to your office. And using a route extraction models won't be able to pick this up. But using that model, it makes it possible. And you can run it at scale as well. So this is in Porirua. And you can see how it took 13 hours to run this. But then I'm just using my machine. So if you have a server or virtual machines that have more graphic card, then you can easily run it at a bigger scale. The last thing that I want to show, promise, 30 seconds, is this is how you can find the models to use the Hugging Face model. So you just go to Living Atlas. You can type HF or you can type Hugging Face. And now I can choose I want to use the object detection. And then you can go to, we're not looking at web workers right now. We're looking at, so this is the Hugging Face model hub. And then I can just copy the ID from here. And then we can just check it in the Hugging Face ID. And now we can run that. I will run it, but it won't work because it will take time and then my laptop is not plugged in. And that's where I will stop talking and pass it back to Rata. Thank you.
Perfect, thank you, Edward. We're running a little short on time for questions, but just to wrap that up, and some great kōrero there from Scott, is I think there's a lot involved here in AI. We hear a lot of words and a lot of technical stuff, but if you don't understand how it's all being done, really just, I think the thing to focus on is to consider whether those sort of outputs are going to be useful for you or your organization. And if you can't figure out how to, put it all together, Eagle's always there to support you with that. I'll just